Hello, everyone. Good morning, good afternoon, good evening, wherever you are. Welcome back to another CIQ webinar. This week, we're going to talk more about Fuzzball, and we have some people that are joining us. So if we could bring in Brian Forrest, I think Dave is with us. Brian. Hello, everyone.
Hey, everyone.
We'll pop them in here too. So I think everybody has met Forrest and Dave. There's Greg. But Brian is new to CIQ, and I would like Brian to tell us about yourself, what your background is in HPC and what you do for CIQ.
Hi, everyone. My name is Brian. I'm a solutions architect here at CIQ. My area of expertise is in running cloud HPC workflows, mainly in the CAE space and also in the area of genomics. Thank you.
Great. Thank you. Sorry, my mic is messing up. So one of the things that we wanted to do, I know Forrest and I have been talking quite a bit this morning. We would like to get a little bit of audience participation. And I'm going to call on Dave Ingram real quick because he was the first one in chat. So if you guys could provide us with some random ideas, just random topics, few words, doesn't have to be complicated, but I think it's kind of fun the more off the wall that it becomes. Forrest, give us an idea of what we're looking for here.
We're just looking for something along the lines of, a cat standing on a hill by a lighthouse, or a Picasso-style painting of Gregory Kurtzer, something like that is kind of what we're looking for here. So yeah, if we could just get some suggestions in the chat, yeah, that'd be cool.
And it doesn't have to be just one. If you guys want to just start, as you're thinking of them, throw random topics in there, we would appreciate it. It'd be fantastic. Just real quick, while everybody's still here, if you guys want to introduce yourselves too, Forrest, you're in the top right. So I'll let you introduce yourself real quick.
Hey, everyone. I'm Forrest Burt. I'm a high-performance computing systems engineer here at CIQ. I work a lot with our Fuzzball system and kind of representing different workloads and stuff like that we want to be able to run on it. Yeah, so very excited to be demoing and to be on the webcast today.
Excellent. And I'm going to go clockwise here. So I'm going to go to Dave next.
Hey, everybody. My name is Dave Godlove. My background is in basic research. I've worked at the NIH and a few other places in that capacity. And I also have some background in high performance computing and a little bit of background also with Aptainer.
Excellent. Thank you, Dave. And then we're going to go to Greg, who is the mystery man this week. Hiding in the dark.
Why am I the mystery man? Oh, it's just the background. And
yeah, you just did it.
So if I don't move for a little while, it readjusts the light settings. So I think the trend here at this point is biologists. And so I'm a biochemist by degree, but turned into high performance computing and open source guy. And I've been lucky enough in my career to be part of a variety of different open source projects and community endeavors and some cool companies. Oh, I don't know if everybody can see this. Rocky Linux V9. So be ready for it.
Was that the background that won?
No. That was just a random one that came up when I first installed, and you can see I'm actually using it, but I put it on on a screen that just has a nice, pretty background showing that it is 9.
Very cool. Very cool. All right, so Brian, I know you've spent quite a bit of time getting something together to show us. Go ahead and tell us what you're going to show us, and tell us a little bit about it. Show us and tell us why you think it's important.
Cool. So what I've prepared today is a OpenFOAM demo for running through Fuzzball. So with CFD simulations, a lot of the time, depending on the size of your model, you may require a significant amount of compute resources, and this can be on the order of in the order of hundreds of cores. So when you're on your on-prem HPC system, you submit your job. Sometimes you'll be stuck in the queue waiting. And if through the use of Fuzzball, we can connect your on-prem resources with cloud resources, and that way you can bypass the queue, get your simulation running on the cloud, and get your results a lot faster. So yeah, let's jump into it. Let me start off by sharing my screen.
While Brian's doing that, we do have a few ideas that have come in. So if you have anything else, shoot it over to us.
Okay. So can everybody see my screen?
We can.
Cool, cool. So I am in this OpenFOAM demo directory right now. In this directory, I have a openfoam.yaml. So how I'm going to be running this demo today is I'm going to kick off the workflow, and the workflow will provision some cloud resources. Once those cloud resources are up, the workflow will begin running on those cloud resources. So let me just start off by kicking off the workflow first. And while we wait for the resources to provision, we can jump into the OpenFOAM YAML and we can talk about what's going on there. So first, to kick off the workflow, I'm going to run Fuzzball workflow start users ethan@cip.co webinar. I'm going to name this job webinar OpenFOAM demo and give it a unique ID of 1, and then I will call OpenFOAM YAML. Cool. And as you can see, my workflow has started. And for me to check the status of this workflow, I can call Fuzzball workflow status. And we can watch this. And then let me just copy the ID here. Boom. So as you can see, our workflow has started. The volume has been created. The image has been pulled, and our job is in a pending state. And what's happening in the background as we speak is cloud resources are being provisioned. And once they come up, our job should be in a started state. So let's jump into the OpenFOAM YAML, and let's see what's going on in here. Okay, so within this workflow YAML file, we have a volume. So this volume is a ephemeral volume, and this is where our workflow is going to execute out of. In this workflow, we have a single job. This job is called run motorbike simpleFoam. Within this job, we are going to be using a image, and this image is being pulled from Docker Hub. It's OpenCFD's latest default OpenFOAM container. And the command we're running here is some bash. And basically what is happening is we're going to be taking the motorbike example from within the installation, copying it to our working directory, setting up our environment by sourcing this bash RC file, and then executing the all run script. So within the all run script, what is going to be happening is we're going to take our motorbike model, decompose that model into 6 parts because we're going to be running on 6 cores, and this model will be meshed, and then the simulation will be run using the solver simpleFoam for 500 iterations. Once the iterations have completed, the results will be reconstructed. So next in our workflow YAML, we have some environment variables that we're setting. WM projector will just point to our OpenFOAM installation. The next 2 allow us to run some MPI commands as root. These are running within the container, so that should be all good. Next, we have our current working directory. So this job will be executing out of /data. So jumping into our resources, like I mentioned earlier, we're going to be running this simulation on 6 cores. And we will be requesting 1 gig of memory. So with our ephemeral volume, we're going to be mounting it to /data, and which is also our working directory for our job. So let's jump back and see where our job's at. So it looks like our job is still pending, and we are waiting for the resources to provision. So once the job is in a started state, we can begin live tailing the logs of this job. And to do that, we can execute Fuzzball workflow. And we can add a -f here to tail it. and we can put in the name of our workflow. So let's just copy and put that there. And we could also give it the name of our job as well. So as you can see above, our job has started, and we can begin live tailing. So let's do that. Okay, so as you can see, our model has been decomposed with decompose par, and currently we are running snappyHexMesh, which will mesh our motorbike model. So I think it'll take a couple minutes for that to complete. Cool.
So I got bounced out of the studio for just a minute due to some technical reasons, but I'm back in. I don't know if you already covered this, but I wonder, you know, for somebody who doesn't really know what OpenFOAM is, might not have heard of OpenFOAM, did you kind of, you know, could you talk a little bit more high level about what it's for and what the motorbike simulation is and so on?
Yes. So OpenFOAM is a open source CFD software that where engineers can run various types of physics simulations. Is typically used for just yeah. So what is happening in this model? We're basically going to visualize the velocity of the wind against the motorbike model. And afterwards, after running these 500 iterations, we should be able to visualize these results in a visualization software such as ParaView. Yeah.
So you might use OpenFOAM, I guess, if you were trying to design a more aerodynamic motorcycle, or maybe trying to design an airplane wing.
Yes,
exactly. That would provide optimal lift or something along those lines.
Yes, exactly.
Cool.
So as you can see, our workflow has progressed. So our model's been meshed, the initial conditions have been set, and right now we are currently at the state of running simpleFoam, and for 500 iterations, which should take another couple minutes. And yeah, we can jump into the comment section just to see if we have any questions.
I think we've got a question coming in from YouTube. Yeah, there we go.
Oh, I was saying that out loud on mute. Sorry, guys.
Control tick in the same way as you would without Fuzzball if read modifiable is equal to true. Yes, you should be able to modify the control dict. So within your workflow before executing, so once your resources are set within the workflow, you would modify control dict, and then from there, when you execute decompose par, your model should be decomposed accordingly.
Thank you, Brian.
Cool.
Yeah, by the way, these comments coming in are hilarious.
I've been contributing and talking with that in the YouTube channel. Yeah, there's a number of good ideas and comments coming through. And I was just about to say, Dave is well known in this industry for dad jokes. we should have some dad jokes as a interlude.
You gotta say which Dave though. There's so many Daves.
True. I guess we'll start calling you Godlove. Godlove, do you have any bad dad jokes?
There's no such thing. But I do have one cute. This is one my son has been telling for years. I have a 6-year-old son, and he's been telling this probably for 3 years. He loves this joke, and the joke is, how much does it take to pierce a pirate's ear?
No idea.
The answer, of course, is a buccaneer.
Oh, that's great. That's great.
And on that note,
So as we can see, simple on that note, jumping back into our demo, simpleFoam has completed, reconstruct par mesh has run. So our results, the mesh has been reconstructed, and then reconstruct par will take all of the partitions that the model was decomposed from and combine it all back together. Cool. And in a more practical case, if you have a bigger model, you would want to run this on multi-node on hundreds of cores. So if you guys are interested in that, please leave it in the comments, and we will be happy to address that in a future webinar. Cool. So that will conclude my demo for today, and I will pass the mic back to Zane.
We do have one more question, Brian.
Oh, yes, for sure.
Yeah, is there some resource monitoring feature? I'd like to find out if all the cores are 100% for the simpleFoam case.
Yes, I believe you should be able to. So how I would check if the resources were fully being used is within Fuzzball, you can get a shell into your job. And from there, you could check if all the CPUs are being utilized from there.
So yes, the answer is absolutely, you can do that.
So you could do it. That's a little bit of a brute force method, but that is a really good idea. I'm going to bring that back, and I think Forrest, Brian, and Dave will probably be doing the same. Bring this back over to the engineering crew, and see if real-time monitoring is something that we could put in for a later release. It's a great idea.
Who's taking that note? Got
it. Zane, I guess that's you?
I got it. I wrote it down. We're good.
Awesome.
All right. Thank you very much, Brian. That was great. We appreciate it. So I don't know if you haven't been reading the comments. This is getting funny. I'm going to turn it over to Forrest. Forrest, we were playing with this earlier today. This has been a lot of fun. You talk about a way to kill a lot of time really quick and get some really interesting, laughable results. So, Forrest, what are we doing today?
Hey, everyone. So the other demo that we're looking at today is an AI model that's kind of making rounds around, the metaverse at the moment. There is a company called OpenAI that they've produced a few different very interesting AI models over time. Text-based ones, I think they call them like GPT or something like that. And then also some image-based ones. They have one at the moment called DALL 2. DALL 2 is massively proprietary. It's something they've trained. You have to wait on a wait list to get access to it, that type of stuff. So it's a little bit difficult to really, really mess around with. But someone has built kind of a miniature version of it that they call DALL Mini. DALL Mini, much like the larger versions like DALL 2, essentially takes in some text input. It's been trained on essentially hundreds of millions, billions of different images of all different types of annotated training data type stuff. And you give it a prompt, and it generates images based on that prompt. So if you give it a cat sitting on a cliff by a lighthouse, you'll get hypothetically images of cats sitting on cliffs near lighthouses. It extends out to being able to do things in different art styles. And I think I might pull these up here in a second because I do have some results for this. But we've got, for example, you can do things like a Picasso style painting of Gregory Kurtzer or a person, something like that. Or of just, basically anything, of a cat, and it'll give you Picasso style painting of a cat. So DALL Mini, typically you'd get access to it. There's a version of it that runs online out there. There's a website you can go to, put in your request. I got sick of having to wait for other people's requests to get done. So I kind of looked into it and realized that, oh, well, this model is freely available out there. You can go and download it and mess with it yourself. So I figured I would turn it into a Fuzzball workflow, and we would see how well that works. So I'm going to go ahead first off and just kind of run through the workflow and stuff like that. And then here in a bit, we'll take a look at some of the results that we've generated. We've had some of these comments coming in so far. I think I've generated a rainbow-colored cow fortune teller, a farmhouse with a cow on the sun, and a squirrel wearing a sombrero in the jungle. So I've generated those. I have some results here. I'm going to look through, or I'm going to explain this workflow real quick so we know exactly where these came from and how this works. And then I'll go ahead and take you through the results we've generated so far. So yeah, I'll go ahead and share my screen. We'll take a look at this right here.
We do have some questions about the schedule we'll get to after we talk about this.
Cool. Okay, so yeah, you can see here in front of me, I've got basically just a VS Code window here. Yes, the font is a little small now that I look at it. So my apologies there. But just to kind of take you guys through exactly what this workflow is doing, this is essentially broadly an example of running AI inference on Fuzzball. So this is not like training an AI model. This is taking a pre-trained model and then actually running, as I said, inference with it. So just to explain what we're looking at here, up here at the top we have a file ingress section. So we're basically just going to, or we have a data volume setup section. So we're going to set up a data volume called V1. This is an ephemeral volume, so it'll only exist for the lifetime of this workflow. We're not ingressing any data into this because the input to this workflow is basically just the model itself and then some piece of text, basically. But we are egressing out these images into an S3 bucket. So that's how we're getting access to these in the end. So this workflow runs, it gets to the end, it generates the images, it tars them back up, and then pushes them out to an S3 bucket. This is and I've named this job a little bit wrong. It should have been, infer model or something like that, but I think I copied this template from elsewhere. So this is not training, this is inference. My apologies. The image that we're pulling down here is basically it's an obtainer image that is based on this recipe right here. So I've taken the script, I've basically just taken the code that the DALL-E mini people provide for their inference pipeline as a part of a notebook that they have, like a Jupyter notebook type thing. I've basically taken that code, put it into a script, and then kind of taken the rest of the setup that they give you in order to get the Docker file for this working and put it in there as well. I built this, pushed it out to a container registry, and I've got it now deployed on Fuzzball. You can see I'm providing credentials to that registry there. The command we're actually doing is the script with the inputs. So you can see that right now we're processing a saddle on a cow in a car race, a screaming gopher caught in a spider web, and Richard Nixon in a tutu throwing confetti. So we'll see how those come back. We have cwd/data. So this is just, this command is being run inside /data. We have a few environmental variables. The most important one is this right here. The pre-trained model I'm pulling down from a website called Weights and Biases. And I basically just stored my API key as a secret within this Fuzzball cluster, so it can be templated out and I don't have to display it openly or manage it outside of just inserting it into the Fuzzball cluster. We're using an AWS G4DN.8x large, I believe, for this. So we've got 16 cores, 120 GB of RAM we're requesting, and then 1 GPU. We're mounting that data volume. And then once this is actually done generating the images, we go down here to tar up the results. So we basically just take the 9 images that we generated, put them into this, drop that into this directory here. And then up here at the top, this egress will trigger and we get the images out. So that's that. As mentioned, the script file that I'm using is basically this. It's basically just their code that they provide for the inference pipeline here, but I've taken it out of their notebook and just basically put it into a script so we can run it that way. Yeah, so that's that. I've been running it. Let's see what this is doing down here, if this is finished or what this is up to. Oops. The VS Code terminal sometimes doesn't like the scroll back here. So let's see what this latest one I'm running is up to. Oh, it's finished. Oh, good. Okay, cool. Awesome. Okay, that means that we have more results now sitting in S3 to look at. So just to kind of explain what I kind of did there on the command line, you can see I'm basically able to control this from the integrated terminals that VS Code provides. So I'm doing Fuzzball workflow status. I'm doing Fuzzball. I can do like Fuzzball workflow log, and this kind of produces a lot of log barf. So we're probably going to see a bunch of random stuff. Yeah. So we get a bunch of different, kind of log output there. You can see the prompts being printed. You can see it saving off the images. So I can, control the execution of this workflow from within my IDE. And without further ado, let's actually take a look at the results that we've got so far. So this is, in essence, the DALL Mini AI model running inference orchestrated with the Fuzzball system. And we're, taking live requests of what we want that to do. So let's take a look at what those have yielded, shall we?
And the exciting part.
I know, right? Let's see here. Go ahead and download these latest pack of images. I've got it set to generate for time's sake. I think if you go to their website and mess around with it, it generates you 9 images per prompt. But just for time's sake, I have it generating 3 per prompt. Did I just download that? 24 I did. Let's stop my screen sharing. Oh, and I do want to point out that container that we're using is running on Rocky Linux. So this model and what we're looking at here is running from an apptainer that's based on a Rocky Linux base image. So just want to point that out. Here is our file of results from the first batch.
Forrest is already smiling. That's hilarious.
So once again, this was a rainbow-colored cow fortune teller, a farmhouse with a cow on the sun, and a squirrel wearing a sombrero in the jungle. So we're just going to go ahead and
we will get to all the questions that are coming up after we see. There you go, Dave.
So there's our rainbow-colored cow fortune teller. I don't know if this counts as an LOL cow demo, but we're getting there, I think. So we've got that. I think these are, I think on the sun may have gotten lost. It looks like we're in the sun here, but here's some cows in a field. Here's a it works remarkably well, apparently, for generating squirrels and sombreros. So, so we've got that. Here's another cow.
Oh, there you go.
Here's more cows in the sun.
Headless cow
in
the sun.
Here's another squirrel with a sombrero. Here's, I think, our final of the 3 cows. And there's us back in the sun again. And then here's our last squirrel with the sombrero. So you can see that this works quite well. I'll go ahead and pull up the other file so we can see some more of our very creative audience's results. This one right here is going to be, let's see, a saddle on a cow in a car race, a screaming gopher caught in a spider web, and Richard Nixon in a tutu throwing confetti. So let's see how this turns out. Oh yeah, there we go, okay. So there's a saddle on a cow, I think. Let's see here. There's a gopher, maybe nebulously caught in a spider web, perhaps.
Spider web, yeah.
Maybe. There's Richard Nixon throwing confetti.
Maybe not the tutu.
Apparently not. Tutu might be a little bit too specific for this model, but we'll see. There's another half-created cow.
Part of a cow.
There's another gopher, kind of, doing something. Here's Richard Nixon partying down again. And then we have our final few, which in general did not come out as close as we got for the last ones, but
He has hooves.
It looks like he's given us his signature wave there, actually.
Wow.
So
that's fantastic.
Yeah, so that's that. That's the DALL Mini model. I'll go ahead and start running some of these additional requests, and I think our plan is to follow up with a post or something like that that'll kind of show off some of the results that we got.
Absolutely.
But yeah, I'll fire off some of these if we want to maybe hop over to some questions or something like that. That was
perfect.
Thank you all for tuning in. That was DALL Mini running on Fuzzball.
Yeah, thanks for putting that together for us. It's also nice to actually show using somebody else's model to run. So that's great. Thank you very much. All right, let's start having some questions. I think there have been quite a few come through here. I know Greg has been answering some of them as they go. I'm trying to go back as far as we can here. So we're talking about schedulers. So does Fuzzball offer a scheduler service similar to something like Slurm? Doesn't matter, you're a newbie, Dave. It's all good.
So kind of. So the way it does scheduling is very different than Slurm because it's more like an orchestrator than just a straight scheduler, in the sense that it can do services, it can do other types of processes, but it's very much like Slurm as opposed to more like an orchestrator in the fact that it can also do rich policies and allocation of very specific hardware configurations. So it can do, it's NUMA aware, it can do multi-node processing, and so on and so forth. It can do a management of consumable resources, and it knows when those consumable resources have been consumed. Again, more like a Slurm scheduler in that case, but again, it's running as a microservice entity within our microservice stack. So the general architecture of Fuzzball, kind of, you can envision it as that there's two clusters running in one cluster. There's the management side, which is running Kubernetes. And on top of the management side, we have a bunch of orchestrating services that run. So we have an image service, a data mover service, a volume service, scheduler service, and get all these different microservices that are all working together and able to scale up and whatnot independently in traditional microservice style. And then we have the compute cluster. Now, the compute cluster is running a very lightweight container hypervisor or runtime VM hypervisor, and it is API driven. So all of the interaction with it is over API, and it is kind of focused on leases. So you can ask Fuzzball, and this lower level, by the way, is called Fuzzball Substrate. You can ask Substrate, for example, I'm going to need 10 GPUs, I'm going to need 30 cores, and I'm going to need this much memory. And if Fuzzball Substrate has that available and can actually allocate that for the amount of time requested, it will respond and say, here's a lease ID. And whenever you want to use that resource, just send me this lease ID, like a token. And then we can go ahead and schedule that. Now, when you have thousands of Substrate instances, you have to manage them now with Orchestrate. And Orchestrate is the next level up in the Fuzzball stack. And Orchestrate is that microservice platform. So you can think of it again as running your Orchestrate instance on top of anything from Kubernetes to VMware Tanzu to any one of the Kubernetes stack. We have a version of Kubernetes that we put together that's super easy to install just to kind of facilitate that deployment. So you can very easily kind of deploy that management cluster, and then you can run the compute cluster using Werewolf, for example, or whatever you want to use to provision your resource. And then that cluster can scale independently. Now, when you're running in the cloud, it's a little bit different in the fact that that Orchestrate cluster is going to run on whatever cloud service provider is offering as a Kubernetes stack. You can run your own Kubernetes stack in the cloud, but it's easier just to use whatever they're providing. And you can run Fuzzball Orchestrate on that stack. So when it's not doing anything, that's the only thing running. And it's a very lightweight, small stack sitting on that Kubernetes resource. As soon as jobs start coming into that Kubernetes instance, that Fuzzball Orchestrate instance, it automatically provisions the compute resources that you need. And so it'll automatically scale up and scale down. So what you just saw in today's demos is, I believe we ran everything up in one of the clouds. I don't even know which cloud. It was probably AWS or GCP, but one of the clouds. And when a workflow was submitted into Fuzzball, it automatically provisioned those cloud instances to then go and run the job, and it tears those cloud instances down when the job is done. So it gives you that ability to kind of elastically scale up and scale down as needed, as opposed to when you're running on-prem and you could theoretically run out of resources. And then you have a job queue that develops, and that queue is now managed according to priorities, just like you'd see in Slurm, not something you'd see typically more like out of a Kubernetes scheduler. I kind of use this question to actually touch on a number of questions that actually came up in the chat and to talk through all of those. So sorry for going on so long, but I was actually answering a few different questions there.
Nope, that's great. I was scrolling through. I think that answers Todd's question as well.
Can I jump in and underscore one of the things that Greg said?
Certainly, Dave.
So he covered so many things, but I think, I'm fairly new to Fuzzball, and I'm still looking at it with fresh eyes, as is, I think, Brian also too. And so one of the things that kind of blew me away about Fuzzball when I first started looking at it and understanding it, and Greg mentioned this, but I just want to kind of underscore it, is so Slurm, a traditional cluster, you've got all these nodes sitting there spinning, doing nothing, or working on other jobs or whatever, but they're all sitting there. There's all these resources. And then Slurm says, oh, okay, you have a job, you want to run on these resources. Let me go look at them and see what they're doing and then run your job. But that big pool of resources is always there. The cool thing about Fuzzball, when it runs in the cloud especially, is that there's no resources there at first. Fuzzball says, oh, let me build your cluster for you, and based on what you need. And then it basically builds you a custom cluster out, and says, here's your new cluster just for your job, runs everything, and then tears it all back down. And that's super cool.
There's another facet of this, which we haven't officially announced. So this is, I guess, a little bit of a soft leak that we're putting out there, but there is a lot of interest recently in composable hardware, specifically around CXL, PCI switching and whatnot. Imagine if there was a way that a workflow can come in and say, I don't need 10 GPUs, I need 24 GPUs. And you obviously don't have that in one system, but using something like a composable switch, we can now actually build that resource and set that resource up. And just like in the cloud, spin that up with that specific hardware configuration, then run the workflow on it, and then again, tear that back down and then put all of the resources back into the pool. So it's quite capable in terms of how you would do things like this. And a lot of that is because we did a couple things when we built and architected Fuzzball. One of them was we took what was working in the HPC community, and we took what was working in the enterprise cloud and hyperscale communities, and we basically picked and choose what is the best for everything that we need to do across this entire, across the entire ecosystem. Let's pull those together, and then let's further innovate on top of that to give us the best platform that we can possibly imagine for doing these sorts of computing tasks. And that's Fuzzball is the result of that. So that's our version of what the best HPC kind of platform could look like. And one of the motivating factors for this was, we've been building HPC clusters pretty much the same way for the last 30 years. The Beowulf design has been incredibly fantastic for us to create HPC systems and drive science, drive research, innovation, and build these sorts of capabilities and scale them up. But, fairly recently, we started to see a lot of new types of innovations, again, coming out of enterprise cloud and hyperscale in such a way that they weren't really compatible with how we've been doing HPC systems. And we've also seen a much greater increase of diversity of workflows to the point where this long tail of science that we used to call it is now actually starting to become the lion's share of the workloads, the majority of these workloads. And we're starting to see that traditional HPC application, those tightly coupled, highly parallelized MPI focused applications are now no longer the dominant and majority applications running on this system. So all of this together really kind of puts right now is the perfect time to start thinking about how do we modernize our HPC environment, and how do we take a better look, a new look, a fresh look at cloud? How do we merge cloud and on-prem in a way that absolutely makes sense, so you're running the right workloads where they need to be run? So all of that is kind of what went into Fuzzball and what we were thinking about when we did this.
Yeah, the next question, a great question too. Does Fuzzball replace some of those capabilities for provisioning like Werewolf, or is it complementary?
So great question. Werewolf is, if you're not familiar, just for if anybody's out there not familiar, Werewolf is a cluster management and provisioning toolkit. It was created back in 2001 when I was at the Department of Energy, and it is still actively maintained today. It is still highly utilized today as this open source kind of cluster toolkit. It does a few things somewhat differently than how you may be familiar with kind of managing systems at scale. And it works on the concept of imaging. So instead of managing operating systems on n number of nodes, you manage a image that goes out to all of those nodes, and those nodes boot on in a dynamic sense. So every time you turn on a node, it automatically does a net boot and is being provisioned this image that you have defined for a single node or thousands of nodes. And you can use the same image for thousands of nodes. And that makes it very advantageous for doing clustering and managing clusters with something like Werewolf. Now, Fuzzball sits on top of Werewolf, generally speaking, just like Slurm and or Kubernetes. If somebody wanted to provision a Kubernetes cluster statelessly, you can do that also on top of Werewolf. So Werewolf is the tool responsible for managing the operating system on all of these resources. But what you run on top of that operating system is completely up to you. So in this particular case, Fuzzball wouldn't replace anything in Werewolf. As a matter of fact, it is 100% complementary in the sense that Werewolf would be kind of booting and running the operating system that's now running the Fuzzball services. And it works very, very good together from that perspective. And you can use Werewolf both for the compute portion of the Fuzzball cluster, as well as the orchestration in the microservice portion of the Fuzzball cluster. However, running Kubernetes, again, on stateless is a little bit different because most people think of running Kubernetes on stateful resources. A few things you have to do there, and just in order to make Kubernetes work properly and feel at home on a stateless system, but it absolutely can be done, and that is one way that we do deploy Fuzzball for customers today.
Stuck on mute again. Thanks, Greg. There was a question, Mystic Knight, welcome back. It's always good to see you. He's asking if there's going to be an IDE plugin that has a menu bar for workflow management in real time.
I'm going to open that one up to I think, Forrest, you've been kind of thinking about this, and if it maybe as well others, but Forrest, tell us how you were kind of using Fuzzball from VS Code, and maybe what are some of the plans and ideas around that?
Yeah, so just to kind of elaborate on VS Code a little bit, I use that a lot for kind of working on, generating my workflows, that type of stuff. It's got the integrated terminal that I can use to, run Fuzzball commands right from the IDE, all that. So that basically kind of makes it the all-in-one easy text editing and working on workflows in that way solution. Some other things that we're kind of exploring around that. I think we're still kind of situating exactly what our plans are going to be to integrate like a Fuzzball plugin for that type of thing. On the workflow side itself, something that we're exploring is the ability to like take VS Code and run it as a workflow. So you can get a VS Code terminal into a compute node somewhere. So that's something that we're looking at. And then we also have, of course, our GUI that we're working on that's complementary to the CLI that you've seen Brian and I kind of demo. That most of the functionality that you see there on the CLI will be kind of available through. So be able to do some of that workflow design, execution management, that type of stuff through our GUI system as well. So that's one kind of big solution there. But I know we're still situating what exactly like IDE plugins themselves will look like for Fuzzball.
And I have heard talk from the engineers about doing a plugin as well. And I think there is already for Aptainer.
Yeah, there is.
I think this is a great idea too. So Forrest, will you ever put that demo into a tutorial document?
Yeah, we can definitely put that out there. I want to point out that it is an open source model. So if you just look up DALL mini GitHub, you'll get the GitHub for it. Like I said, my modifications there have been to move their Docker-based container over to Apptainer, and then to take their code out of the notebook and kind of reconfigure it a little bit so it can save off the images instead of just displaying them into a notebook. So all credit for the model and stuff like that goes to, I believe his name is Boris Daima or something like that, if you look at his GitHub there. So all credit for that itself goes there. But yeah, we can definitely make available some of the tutorial materials for people to mess around with. Like I said, I modified it a little bit, pretty simply, to make it take in input on the command line and then to make it just save off those images. So yeah, that's something that I'm sure we can make available.
How long did it take you to get it to work, Forrest? When you started setting out to play with it?
It took a little bit. Most of the stuff I ended up doing was just kind of code level debugging. As far as the actual Fuzzball part of it itself, once I had the image going and the script itself kind of all sorted out, so they're running the errors with that, it was essentially just as simple as dropping it into a Fuzzball workflow and then figuring out what resources it took to run optimally. So yeah, the workflow creation process was fairly simple. Like the script debugging, that took a bit, but dropping that into a workflow and getting that workflow running was pretty simple.
Of course, the bigger lift would be getting a Fuzzball cluster running, and this is something that we are planning to put up demo instances up on the net so people can actually use this. Timing for that's still a little bit further out because that technically is kind of like a cloud resource, a cloud platform. So that's a little bit further out, but yeah, that will be something that you're going to see here pretty soon.
Very cool. Thank you. Thomas Knight has another question. So I think we talked about this a little bit last week in the roundtable, but given that university labs have a lot of high-end workstations, can you federate over a campus, multiple campuses to those high-end workstations? And can you put them into a single cluster during their idle times?
Yes. So in terms of workstations is a little tricky. Most people are not building HPCs out of HPC systems, out of workstations. That is something that was actually kind of a big deal a little while ago. As a matter of fact, it was one of the reasons why a lot of people liked the name Werewolf, because they can convert their labs of workstations to a cluster at night under the full moon. So anyway, that was one of the reasons why a lot of people liked Werewolf, and it actually kind of went out. It got very popular because of that, because Werewolf is completely stateless. So you can actually have locally installed Windows systems, have them boot to Pixie first, and then when you reboot those systems, when you turn on your Werewolf control service, they will automatically all turn into cluster nodes. So we actually there was a lot of people in computer labs doing that. Now, since then, that was again kind of early-ish 2000s, mid-2000s. Since then, most people have been focused on building kind of just production, clusters that are dedicated for that sort of those sorts of work jobs and whatnot. But in either case, if you want to build up multiple HPC systems, I talked a little bit about Fuzzball Substrate and Fuzzball Orchestrate. Those two is what makes up a single kind of cluster resource. There's another level of Fuzzball which sits above both of those called Fuzzball Federate, which does exactly what you're kind of, I think, asking, which gives us the ability to basically link together and join and unite any number of separate Fuzzball clusters. And these clusters don't always have to be just on-prem. They can be in the cloud. So you can have, let's say, Fuzzball resource in different colleges within a campus. You can have different campuses. You can have them a Fuzzball, multiple, let's say a Fuzzball cluster in AWS, a Fuzzball cluster in Azure. But maybe in AWS, you actually want a Fuzzball cluster in multiple availability zones to ensure that you can always hit GPUs when you need GPUs. They're actually getting kind of hard to get in various clouds. So this gives you the ability to automatically kind of choose where do you want to run, and maybe that's in Azure, maybe that's in GCP, maybe that's in another campus's server room or data center. So there's a lot of optionality and a lot of functionality in terms of this architecture. And what you're seeing, and what I think everything we demoed today was just going straight to a single cluster. At some point in the future, we'll start really demonstrating and showing off federate. But right now, we're still focused on orchestrate and just kind of demonstrating through orchestrate.
That's great. Thank you. I think that was all the questions we had. If you guys have any more questions, post them now. Give that a minute. I want to thank Brian. Thank you for putting that together. That was great. Thank you for spending the time for us. As always, we really appreciate it. Dave?
I gotta say, yeah, I really, really love demos like this. Demos that you can kind of visualize and think about, you know, like what Brian put together as far as modeling, and you know, you can really kind of understand what's going on an intuitive level, and also just like really fun demos. As everybody, you know, who knows my history knows that I really like to make sure that there's some fun and some humor in demos to keep you engaged, and also to, you know, they're just fun to work on. And so I love stuff like this.
Absolutely.
Really?
Thanks for the dad jokes too.
There's more where that came from.
Really quickly, I have the last 2 batches of results from,
Oh, nice.
I think, the other requests that we had, if we want to close out by looking through those.
Absolutely. Let's do it.
Once again, this is a Fuzzball workflow that I engineered to use this model to use Fuzzball to orchestrate out actually running things with this model. So I just want to make it very clear that everything you're seeing here was generated from that workflow, and that you know, was all run on Fuzzball at an AWS data center on resources that it orchestrated there. So very, very cool. Let me just go ahead and share my screen, and I'll show you our last few Fuzzball results here.
Could we also post all of these images somewhere? So maybe from the YouTube link, so people can actually go and download them and hang them on the walls, and maybe make some amazing NFTs from them.
Exactly, yeah. Okay, so this is a diver drinking coffee in a mountaintop cafe, a screaming spider caught in a gopher web, and 3 dogs playing with an elephant on Mars. So let's see how these turned out. Let's see here. There it is. Okay, so there's a diver, not exactly on a mountaintop, but a diver at least. A spider in a web.
Spider web.
So maybe it's a little too novel to have a whatever I just said, a screaming, what is it? It's a screaming spider caught in a gopher web. So maybe that spider is screaming and we just can't hear it because this AI doesn't generate sound. Here's a bunch of elephants and dogs. It looks like maybe playing some soccer or something like that on the Martian surface. Here's some divers. Looks like having a cuppa at the bottom of the ocean.
Coffee, there you go.
That's cool. Looks like maybe even have like a little coffee cake or something like that right next to it. Here's another spider in a web, but noticeably distorted. Here's a little bit more of the great, I guess, animal conference going on Mars. A little bit of a mishappen diver there. Another random of a spider. And then more going on Mars. And then I've got the last one. I hope I got them all. I think I got all the requests that came in. I don't think I missed any. But this last one right here is a bison on a keyboard, a space shuttle backpack riding on an elephant. And I didn't have a third one that I could see, so I just put in a CIQ branded supercomputer just to see what we get. Let's see.
You didn't do the Van Gogh style painting of Gregory Kurtzmer?
I didn't in this round. We can probably. I've got a couple of those, I think. So I think that we could. Oh yeah, that looks really good. So I think that we could probably.
Could we not do me? I'm just saying.
Let's see here. So we've got a bison on a keyboard. Let's see here. What was this? A space shuttle backpack riding on an elephant.
That
So
one's
that's-
actually pretty accurate.
That's looking good. Yeah, it looks like we've got like a strap there and stuff. Here's our CIQ branded supercomputer. This looks like
Kind of the CIQ colors.
yeah, it's got a little bit of a green hue to it. This looks like the the rack of servers that Jonathan is in that photo that's everywhere in.
You know what? I think you're right. We gotta bring that up with Jonathan.
Here's it looks like here's a bison sitting on a space bar. It looks like. Here's another elephant with a space shuttle backpack.
Maybe backwards.
Maybe. It might be. Here's a green supercomputer. Yeah, that's definitely
got the color.
Getting a little bit more CIQ
You know, I
brand
do a lot of presentations nowadays. I think I'm going to use that one.
Perfect. Here's a bison on a kind of free-form, maybe touchpad keyboard.
I think I might have to use that one too. I'm not sure what. I'm going to put it into a presentation somewhere.
It looks like we've got not only the spaceship, but the whole crew here. And one more supercomputer. So not supercomputers, I guess, are maybe not. They're pretty uniform, I guess, when you look at millions of them at once, or millions of pictures of them at once, I guess. Cool. Yeah, so that's all those. Yeah, fun times. Thanks everyone for tuning in and for having some fun with us on those.
So I think what I just learned is every time I need an image for a presentation, I think I'm going to start bugging Forrest with a bunch of keywords. Forrest, I think going to be in your best interest to post that workflow as a template somewhere live, so I'm not bugging you every time I'm making a new presentation.
Perfect.
You can set it up as a service in the marketplace, so you can just go download your own.
Really quickly, I shared my VS Code screen. I just want to point out, just to link it back to what we said about there real quick. Once again, this is the workflow this ran from. These are like the logs being printed out of it, and all of this execution, for example, like starting this workflow, logging this workflow, checking the status of it, that type of thing. As I mentioned, I did that all from within VS Code and their terminal and stuff in there. So very useful, but just kind of random note to show just once again how that, how I've been running these commands here. Typically I pull up a terminal, but just to show you guys where those are coming from. So
while you're in the middle of a webinar, you did all that. Very cool.
I appreciate the creativity and the responses that we got. That made it very, very fun. So
I also like Dave Ingram's last comment about Rocky Linux 9 codename Bison Keyboard.
Blue Onyx is the code name for Rocky Linux 9, but Bison Keyboard could be a good one for the next.
Maybe
Although it's not really a rock or a color, but
Exactly. Most ergonomic keyboard ever. Looking through the comments. Exactly. Cool.
I love it. Well, thank you guys very much. We appreciate you joining us this week. Look for these images to be posted somewhere. We'll link to it from YouTube. So we'll get those out there, and Forrest will work on getting a tutorial out on how to get this done for yourself so you can waste a lot of time spitting out random images. So we really appreciate it. Thanks for your time. Thanks, guys, for joining us.